atomic oxygen at different altitudes, or pollution monitoring, where you can determine different amount of different types of gases available in the atmosphere at different altitudes. So these are all possible by remote sensing applications. So other kind is microgravity experiments, like so space is where the gravity is less, so because it is far away from the earth's surface. So in microgravity, in outer space where you don't have atmosphere, much of atmosphere, where there is vacuum, where there is a lot of ions and cosmic radiations happening, solar flares happening. So a lot of different types of experiments can be conducted, which cannot be happening on Earth due to gravity. So apart from this, there are other applications in robotics, where we can design the landers, where we can design robotic arms and debris detection and debris collection. So those kind of applications are also possible, and those can be implemented using satellites as small as CubeSats. So, while determining a satellite mission, so determining your space application and determining the payload required to achieve your space application is very important. So, determining your payload is what defines the mission of your satellite. So, that's why payload becomes, very important part of the CubeSat, because from payload you decide what your mission is, and from the payload you decide what your satellite bus is, like how much power is required for your payload, how big is your payload, what is the size of your payload, and what type of orientation is required for your payload, what type of stability is needed for your payload. For example, if you have a camera as your payload for any earth observation application, then you need more stability than a communication kind of satellite. So payload is, the deterministic factor in the entire satellite mission while you are designing a satellite. And then payload also decide whether you have to launch a single satellite or a multiple satellites, that is constellation of satellites. For example, if you want to have a technology like inter-satellite links, so you need to have a minimum two satellites in orbit to demonstrate the inter-satellite link. So, payload influences the system design very vastly in terms of power, in terms of volume available, in terms of cost, and also limitations of the satellite, stability of the satellite, etc. So, a lot of innovation, a lot of thinking outside the box happens when we are determining your satellite mission and determining what your payload is. So this is an example of a one new satellite configuration. If you can see just a picture of how a fully assembled, ready to be launched satellite looks like. So it's a one new size of satellite where the dimensions are 103 mm by 103 mm by 113.5 mm, which is designed according to the CubeSat standards. So it has six solar panels along all of its faces of the satellite, and you have an antenna that is a monopole antenna for UHF, which VHF sort of communication for the satellite communication from orbit to the ground station. And the stabilization of this satellite is achieved through magnetometers and magnetotalkers. And apart from that, it has sun sensors and magnetometers for achieving the stabilization, and also sun sensors are required to monitor whether your satellite is sun facing. So this is one example of a payload which can be achieved through a one new satellite. So the application here is for magnetic field mapping of the entire globe, and the payload is a magnetometer. So we launch a 1U CubeSat with magnetometer as a payload, or four magnetometers to be precise. We launched the payload contains four magnetometers located in four directions of the satellite. So when we launch this satellite into orbit, what it does is it measures the magnetic field at different points on the globe, at different locations on the Earth. So thereby we can see the variation in magnetic field happening around the Earth. So the example over here is we can see the blue spot, which is called South Atlantic anomaly. So around this region, the magnetic field is very high, and that in turn can affect the functioning of other satellites, and it can damage some of the satellite operations which is on orbit, because the magnetic field is very high. So the reason for magnetic field being very high, because the north pole and the south pole of the earth is different. The magnetic north pole and magnetic south pole of the earth is different. So at South American region, wherever we see the blue spot, that is the magnetic south pole of the earth. So we can have these kind of applications and these kind of payloads. So this is an example of a remote sensing payload where we are mapping the magnetic field of earth. And coming to see, like for designing the payloads, you have to think out of the box. Then for designing the satellite, you have to know what is inside the box. So this is the exploded view of a satellite where you have a structure. The structure is made of aluminium mainly, because aluminium is very lightweight, and it can withstand the external space radiation in the orbit, that is in space. So you have solar panels which is located on all six surfaces of the cube. Then you have a payload board. Then there is a OBC, that is onboard computer and a communication unit, and you have a power module, and then there is antenna which is attached to the solar panel, which is at the top of the payload. So these forms different subsystems of the satellite system. So coming to the yeah, so here we can see the satellite structure, and here we can see how all of the boards are compactly arranged above one another. So this can be, perfectly situated inside this satellite structure. So coming back to here, so the different subsystems of a satellite, irrespective of the size of the satellite, is you have a distinctive payload. So depending on your payload, the capacity required for onboard computing is calculated, and then you have that kind of onboard computer. For example, for a smaller satellite, you need lesser computing power, and for a bigger satellite, you will need more computing power, where the OBCs are designed with system on chips, or very high-end processors. And then the depending on the type of payload data, so the communication frequency, or the communication band which is required, and the data rate at which the payload data has to be transmitted to the ground station are determined. So for example, if you have a imaging payload where you have hyperspectral imaging or SR imaging, the amount of image data is very huge, because each image is made up of very high number of pixels. Then the data required to send one image to the ground station is very high. It is not possible in UHF VHF kind of frequency range. Then you will have to design for a higher frequency range, like S band or X band. So that's how selection of your payload also helps in determining your communication system. And then very important is the power module. So in space, the power is generated mainly through the solar power. That's why we have the solar panels. And the power generated through the solar panels are stored in the battery, and the battery power is also made used for working of the satellite. And we have antenna. So the digital signal in the communication system is converted into electromagnetic signals. So those can be transmitted through the antenna, and these signals are received at the ground station. So the ground station also should have similar kind of equipment in the similar frequency range as we have in the satellite for correctly downloading the data from the particular satellite. Yeah. So coming to satellite communication, so this is one of the very important aspect once your satellite is on orbit. So if we don't have the communication system working properly, it is as good as we losing the satellite, because we are launching the satellite for getting some kind of information, for getting the TTNC data, for getting the payload data. If we are not able to receive the signal from the orbit to the ground station, it is as good as like we have lost the satellite. So designing communication system is also one of the very innovative fields and very challenging fields. So here we can see there is a uplink frequency which is also called as telecommand, where we can give commands to the satellite to change something or change any of the operations, and the data coming from the satellite is known as downlink. And the downlink frequency is usually lesser than the uplink frequency, through which we download all of the payload data. From satellite, two types of data are sent to the ground station. The one is telemetry and telecommand data, and the payload data. So TTNC data mainly gives information about health of the satellite, whether the satellite is adequately powered, what is the battery charging information, whether there is error in any of the subsystems, whether any solar panel is damaged. So TTNC data consists of like temperature reading, voltage and current readings, and also log about whether all of the subsystems are working fine or is there any sort of error. So depending on the telemetry data, then we can send the command to rectify the error or reset the satellites, or get back the satellite from an error mode. And next is payload data. So depending on your satellite application, depending on your satellite payload, so we get different types of data. So one more aspect we have to keep in mind while designing our satellites is space radiation. So the satellite mainly consists of electronic boards and mechanical structure. And in outer space, we have free protons, free electrons, and cosmic ions, which are traveling from larger distance from the entire galaxy, traveling into space. And these ions have the capability which can damage the electronic parts on the satellite. So they can damage either the processor or the memory or the logic system of the satellite. So to protect the electronics or protect the entire satellite from the space radiation, we have to have some mitigation techniques to protect the satellites. Like it can be a hardware mitigation technique or a software mitigation technique. So in terms of hardware, so it is like having redundancy in the design, that is having multiple processors. That is, if one processor fails, so we have another processor which can take over the system. So CubeSats are so small that when they are in the launcher, when they are allocated on the launcher, they cannot withstand the high vibrations which is there in the rocket. So we use something called deployers, CubeSat deployers. So we place a satellite in the deployer, and the deployer is placed on the rocket. And when the rocket reaches the orbit, when the rocket is launched and it reaches the orbit, so these CubeSat deployers, they release the satellite into orbit. And when they release the satellite into the orbit, it is basically in an off position, and another function of deployers is to turn on the satellites when they are released into the orbit, so satellite can start functioning. So under 75 student satellite mission, so this is one of a very good initiative which is with through ITCA, and this is one of the biggest skill development program, I can say it is happening in India right now, where we introduce the satellite technology and space technology to all students. And UnitySat is the first student satellite which was launched through the 75 student satellite mission. And now some of you will also be involved in designing another satellite which will be part of this 75 student satellite mission. So about Transcend, I own a space startup. So we provide end-to-end solutions for and launching a satellite. So here we can see a model CubeSat or a CubeSat kit, which functions absolutely similar to a one new CubeSat, and this is designed for lab use where students can have hands-on training and on working of a CubeSats. Like it has every subsystem which a one new CubeSat should have. It has a GUI system which can be connected to the laptop, and you can perform different activities like reading the telemetry data, reading the payload data. It has a LoRaWAN through which you can transmit the data up to 1.5 kilometers. So this is one of the products which Transcend is doing to contribute to the space education in India. Yeah. So thank you so much for your time.
So we now request Mr. Dr. Jayakumar Venkatesan, CEO, Wellness Marines International Private Limited, to come on the dais. Sure.
Hi everyone. So how is energy today? It's like lunchtime or no? You have energy to listen. Something I'm gonna to give some small boost actually. Like I was a part of $40 million Google mission as a chief to take care of the lander and doing something. Something I will show you some excitement, something like you can be able to like what is moon and something is going on. Okay. So you can see there's a small rover that was a part of that Google mission. So, but we are not successful, but we tried to do it. But more than 1 decade we worked on that. Okay. So that you can see in the picture, like in the right side. For me, in the right side. So that is the one of the lander, micro lander that is going to be going to moon by end of this year as a part of Artemis program. So I'm sending my DNA to moon in that lander. Okay. So I will show you the details. So mostly the lunar exploration, as you know, like moon, we know vada and all, like like we eat vada and snacks, something like vada, right? Our grandma is preparing vada and moon, something like that. So we try to explore whether our grandma there or not, something like that. we are exploring, like decades of the programs like Apollo and Russian lunar programs, and also now the NASA is tremendously working on various mission perspectives. So maybe we can be something like tourists or maybe the colony on moon, something like that. You can see, you can wear the spaceship, the shuttle, like maybe something kind of moon fort. So there are the various missions right now. Early missions have been like, I'm not going to discuss about the history, but what I'm going to do and what current status right now. As you know, like this is the Chandrayaan, but I'm not working anywhere in Chandrayaan, but it is for our country and pride, I can say. But the Chinese programs also on another side, they are contending into the new space missions. So what we do is from our portfolio, we are working on mostly space. Our idea is mostly to explore the moon. That is our primary agenda, and our activities are more focused on moon. And the secondly, we have wanted to do some International Space Station experiments. So we done the world's first living tissue we printed in the space before any space agency is done. World's first organ printing experiment in space. Okay. Now I wanted to do on the moon. So I can show you the bioprinter, like how we printed, how we constructed the 3D printed organs. That I will show you. And apart from that, I'm also working on small satellites as one of the new vertical. I mean, like something like we are demonstrating some commercial things, something that mainly for technology demonstrator or whatever so called. But we will majorly be focusing on ISS and Moon and other space exploration missions. And we are also do inspire the young generation. How many of you guys want to be an astronaut? Can you raise your hands? Who want to go to space? Only. Why not? I can't see many numbers. Like very few. They don't want to go to space. Oh, okay. No, you also. That's nice. Cool. So for you guys, we have one entry level. Everybody can't be an astronaut or somebody, but we have a facility in Poland. It is supposed by European Space Agency. So we can spend 1 or 2 weeks as you can be a cosmonaut or astronaut, and you can spend yourself and train yourself like an astronaut. That we are providing in Poland. So if you want, you can feel free to reach out to me. Okay, I can make you at least 1 week astronaut, 2 weeks temporary astronaut. Okay. So then we have many international collaborations with the government, to government and private and the space agencies in our capacity. And so the first image you can see, there's the cosmonaut training, astronaut training simulators that it's me and I'm working on. We trained several astronauts. We helped them to fly to space. We helped many astronauts to fly to the space, and we are doing now in Russia, but now in Gaganyaan we are trying to, the negotiations, things are going on to training some activity in India, in ISRO. And we have established some few collaborations with the government and non-government. And this is the beautiful thing. This is the project I worked as a chief, and you can inspire the story of how we are landing on the moon and what you are going to do on that. But Chandrayaan 3, maybe the replica like this. Can you play that video? You can play separately the video. Escape. This side audio. You can play from the past. This is the liftoff, as you know. Can you please?
Who will make this daring attempt to win the prize?
It's visible. This is visible.
Which spacecraft will survive the 400,000-kilometer journey? Which team is going to land on the moon?
This is what you know from Chandrayaan, right? After that, no information. But now this is the last situation of Chandrayaan 2, right?
Connection to lander lost.
So now this is the story
We still
after
have no
that. What you
status
can able to
update.
achieve.
Signal acquired.
We're down safe and on the moon. Well done, guys.
What message will the successful team send home? The first word sent from the lunar surface in more than 4 decades. But the race hasn't ended yet. The spacecraft must travel 500 meters and send back more video and images to win the X Prize.
This is what you see from the rover. You can see the controls.
As the spacecraft prepares for the final part of the competition, where will you be?
So this is how the rover will deploy from the lander.
Will you be cheering on your team? Will your team take the prize?
490 meters. 491. 492. 93. 94. 95. 96. 97. 98. 99.
So this may be the future. You know, like you can go to the moon and back to Earth.
These expeditions will take us back to the moon. For good.
So how was it? So this is was the mission, that our earlier mission. Now we wanted to try to do something with Artemis. Can you? Oh, okay, okay. So now I want to be a farmer on the moon, like to cultivate some potatoes, tomatoes, something we can grow, like a lunar factory. You know, we can say Vivasai. So you can see this is the 3D bioprinter. World's first living tissue has been demonstrated in ISS missions. So this was the printer. And the next one will be like 3D printing on moon surface. You know, like we can produce using the lunar soil and to produce some of the materials. I have something in my to show. This is the lunar soil simulant that we fabricated some of the components. We are trying on this R&D as an experiment. Okay. So if you wanted to see, I can show you later. Okay. Okay. So these are like we are working on real missions and real challenges. And something what we are going to right now. So this is the lunar lander that was developed in Bangalore. Okay, so I mean like was a part of the team Indus, and we are also signed up with going to the moon. And in 2018, ISRO, and also we have cancelled this mission due to some technical and other aspects. So the member of parliament from Vietnam, they paid the delegation to us for that time. We took the picture. And we trained the real astronauts and cosmonauts in Russia. So this is what we train. These are the cosmonauts. That is, they are the real astronauts who went to space. So we supplied and we demonstrated the simulator for them to train. I want to build such a. This is I want to take care of our children and for our country, the people. So I wanted to build a small center like this. You can play around to fly yourself to the space. Maybe I'm finding some university guys in India, so I could able to build some small space park. There we can able to play around something. So and also we give them virtual reality and augmented reality and you can fly yourself to the space. So we are in the born with the technology. So this is the 3D bioprinting experiment how we done in our International Space Station. You can that will be like we have the inkjet like same like printers like we have the different bone or something different material and all like these and all taken from our cells from human cells that we can able to make new organs. So this is the big breakthrough actually. And this is the space from the space station. Like this is before launch. It's like a 14 kg bioprinter. It has many cartridges, and you can see here, like how the construction is happening. Like how the biofabrication is happening, like this, from the organ. And this is what I want to do on the moon. I'm going to take maybe Elon Musk, Jeff Bezos, whoever is funding this project, and I can take them stem cells. I will produce the micro organs on the moon, and this will be maybe you can go or you can't go to the moon, but at least your organs we can fabricate on the moon. So this is what our plan, and we will plan to broadcast from the moon to Earth to show off the how we are doing the biofabricating the instruments. So other satellite mission, something like we are also working on small satellites as well, and other connectivity solutions we will be looking into the, for example, like different connectivity solutions, centralized and Uberization, and making something like affordable services with the various case studies. And this is what the future, like people are working in artificial intelligence, like we always work with AI, also as a supporting member, like a buddy to whatever we do. And it's like driving our integrated circuits, like for example, integrated detection and tracking of many architectures and together something, we can connected devices, connected humans, connected animals, everything. Together, plants, everything. Like that is its complete ecosystem. We have to be in following it up. And still we have reached to International Space Station, our missions. And now we wanted to go to the moon and Mars. So that was the aim. So now our next target is on the moon, that we wanted to accomplish some of the experiments on the moon that we can do. So now I'm looking for something really very interesting topic. As you know, like many of you guys know about like navigation system, but this is completely new on the lunar navigation system. Like there is no navigation systems and exist so far in lunar navigation actually. So in Earth we can do all GNSS, but how do you on the lunar surface? Lunar navigation system, satellite system. There is no navigation satellites much. Like this first time in NASA is going to be demonstrated by next year. So we are exploring with multiple options like lunar factories and human vicinities, and also maybe a lunar space station, something like that we are working on. And you can see this is some of the studies that we have carried out for the lunar navigation studies. So you can see there will be like we are trying to achieve something 10 kilometers at 10 centimeters per second. That is the performance we needed on navigation when you are navigating on the moon. And currently we are in the stage of GNSS that lunar, like this is the lunar navigation subsystems that we are currently We are into the research and developing, and currently in terrestrial genesis is there, but lunar can be in the future. So that we are working on. And I told you that Lugri is the mission that is going to be happen by this year. So that mission is carrying the DNAs to the moon. And Lunar Pathfinder, they may do the testing the new equipments like Lunar GNSS missions. That is a partnership with the ESA and NASA. So this is what how my DNA will go to moon. This is something like our mission profile. So I don't want to jump into too much technicality, like to going on. So these are our approach, and these are the communications on the lunar surface. Especially we focusing on mostly lunar communications with the different bands, communication bands, and also position navigation and the timing and tracking what we do, something on the moon. And this is the lunar communications have been established now. Now we can put the network relays, so that we'll probably can able to achieve. So stay in touch. I don't want to too much things to discuss, but like if you like to engage, to feel free to contact to me. And this is one of the beautiful picture. That this photo being like in International Space Station, me and my friend cosmonaut colleague, they placed on International Space Station Cupola deck on Human Space Flight Day last year. So this is my contact number. So if you like to contact me, to feel free to reach out to me. Thank you, guys. Thank you.
Thank you, sir. Now I call upon Ms. Bhavna Sawant to take over this dance. Check. A very good afternoon, ladies and gentlemen. Are we all hungry? All right, so I'm not going to take a lot of your time and not too much of your hunger energies nor your brain energies, but I'd like for you to spend 15 minutes with me so I can take you on a journey along my space journey. So if you resonate and if you think that there are things you want to do, I might be able to tell you what I could, so you could do more. Yeah? Well, what great honor beholds in this moment to share this platform with minds that bolster the wheel of space. They say if you write a better book, preach a better sermon, or even make a better mousetrap than your neighbor, although you build a house in the woods, the world will make a beaten path to your door. And on this auspicious day, which adds another feather to the Indian space cap, the world awaits. I hope that someday the world can make a beaten path to your door too. Quickly, without further ado, I would like to take you on my space journey. Before I could go to the step one, there's a small thing that I would like to narrate. So, as I embarked on my engineering journey, as you all have, my chance encounter with my mentor in my freshman year changed my trajectory. It enhanced my journey further on. So you already have a platform with great mentors, great support system. So I hope you can truly understand what is already given to you. In my case, it was Professor Dr. K. Gopalakrishnan, my mentor. My encounter with him in the first year led me to a world of opportunities, and the space field is one of the many. Having said that, in my final year, I was chosen to be a part of a student exchange program. Do you all have a student exchange program here? Yes? Yes? No? All right. But there are many opportunities that you can tap into to have a more international exposure. In my case, that opportunity came in my final year in engineering, where I was chosen to go to France for a study exchange program. During that time, the 6th UNISEC Global Conference was held in Strasbourg in France. And it was at this point that a lot of our efforts previously done culminated, came together to bring home a UNISEC chapter. Do we all know UNUSA? How many of us know UNUSA? Put your hands up for me. Okay, we all know United Nations? Yes, good. So under United Nations, there is the Office for Outer Space Affairs. So everything that happens in the outer space, there is also a UN body that is governing and also propelling the movement forward. Okay, while this is happening under the United Nations Office for Outer Space Affairs, there is a committee called the United Nations Committee on Peaceful Uses of Outer Space, UNCOPS. Under this, like how you might have your IEEE chapter, there is something called the UNISEC chapter, which is University Space Engineering Consortium. I'm going to lay emphasis on this because I know that you just got your chapter today. And the chapter to India came when I was there, and the Indian team, I was a part of a 3-man Indian team that represented India at the Global Forum and the 6th UNISEC Global Conference and brought home the UNISEC India chapter. It is then that I was able to interact and truly take a peek into what lies beyond my horizons, to understand what opportunities lie for students, how you can tap into nanosatellites, picosatellites, CubeSats, CanSats, and so on. At this juncture, as you can see, it was on this day that India officially received recognition under the UNISEC umbrella, and we were able to bring home the UNISEC India chapter. The person you see, as most of you might recognize, is Rei Kawashima. She's the Secretary General for UNISEC Global. While I'm still here, since we're talking about small satellites but big applications, during this conference, there was one specific talk that went on. It was about commercialization of small satellites. We all know it's really cool to probably build small satellites. You have satellites that are like the size of, my finger, things that look like chips. They're so thin, they're so compact. But why do we need them? We already have Chandrayaan, we already have Mangalyaan, we have such big satellites, we have the INSATs, we have the GeoSats. Why do we need them? Even if we build them, like how Vairasrajan sir very specifically mentioned, where's the money in it? How does it benefit the society? How can you commercialize it? You might tomorrow want to enter the space sector, but how do you build an economy around it? How do you commercialize it? This was one of the agendas of the 6th UNISEC Global Conference, and just to give you a peek into it, you don't have to be noble just to build satellites, but it comes as a byproduct of the whole process. That is to say, some of the basic applications of small satellites could be used to help fishermen, to help them understand about the currents, the tides, whether it is the right time for them to go out and fish, to alarm them. It could be to detect forest fires. You might be able to alarm the officials in time to save a large portion of the forest. We've all heard about the forest fires that have wrecked or ruined acres together of the geological well-being that we have today. For example, if you're an adventure enthusiast, let's say you enjoy surfing, you enjoy diving, and you know that there's a Great Barrier Reef which has got beautiful corals, but they're all dying. Through small satellites, you might be able to detect the rate at which coral bleaching is happening. You might be able to help the ecosystem by protecting them, by enhancing tourism in those regions, but also safeguarding and protecting them in that name. So not only is it going to be fun, not only is it going to make you money, not only are you going to commercialize your own satellite, but they're also going to contribute to the dwindling ecological factors or the deteriorating climate change. So these are just some of the facts that some of the opportunities or possibilities that we were exploring in that forum. So these are, maybe you can take home some of these pointers if you're enthusiastic about nature, if you're enthusiastic about just building some tech to do something cool, make money out of it. There are a lot of avenues that you can explore. Next up, being a part of UNISEC also gave us a lot of access to repositories of countries that are spread across the globe to understand technology. It's a shared forum. It's not competition, but rather co-epetition. So you have this ecosystem where you're competing, but also ensuring that you're walking together ahead. Yeah. So on that journey in 2019, there was the International CanSat and Rocketry Championship held at Serbia. These are the opportunities that you might also have at your door. So I hope you can grab them on. In this, I was mentor for Team India. We had about 3 teams that participated that year. And the first and the second place were backed by the Indian teams in 2019 in Serbia. It was rather new. Let me tell you that this was just the point where we were all so excited about, oh, satellites, they're so cool to build, but they might be really elaborate. It might be really difficult and extensive. I will not take away the difficulty that lies in building it by saying it's a cakewalk. No. We had to put in a lot of hours, burn the midnight oil, and make the journey happen. But was it all worth it? Did it feel like it was an impossibility? No, it was most definitely worth it though. So here's just how it looked. Within about 3 months or 4 months of time after understanding that we will be competing or participating, we had to make all different kinds of designs. We had to stack them differently, come up with different innovative ways to make an unconventional CanSat. I was just telling my niece today that imagine fitting an entire satellite into a soda can. And she was like, soda can? Is that even possible? And then when you think about it from that perspective, it's so much fun. It's intriguing to think that what can fly beyond what you can see, you can create it in a way such that you can see, visualize, and understand how it works while you're here just by participating in forums like these. So this is how it looked. So that was the CanSat we had built. That's the parachute it came down flying with. Can I play this video? Oops. The previous one, the 6th one. Could you play the 6th one? No. Okay, even if it doesn't take off here, it did. So it was in this very rocket that you can see the nozzle, and you can see that structure below that. That's where 2 CanSats were stacked, and they were launched, and they came down with their parachutes, sending telemetry data to the ground stations that we'd all built. So this is something I hope all of you are already doing. If not, I hope you all take it on and have some fun. Up next, in 2019 is when we understood how the nitty-gritties of just building a basic satellite would work. But now it was time for us to make our own satellite and jettison it into the orbit. So for over the 2 years, from end of 2019 until February 2021, my team and I, under the leadership and guidance of my mentor and many other scientists from the ISRO fraternity, came together in helping us build our own satellite. So it was a constellation of 3 satellites. We called it the Unity Sat, because it had many minds from everywhere that collaborated to build and launch. And working alongside ISRO for the launch facilities, we were able to launch 3 Pico satellites. Basically, they all came together as one cube, which had 3 sections to it. Each of them probably weighed about 300 grams. So in all, you can imagine a constellation of 3 weighing around a kilo that was launched into the orbit on 28th of February, 2021. And 3 colleges were involved in making this. And I was part of the team that was able to achieve this. As you can see, this is Sriharikota. This was what we witnessed live standing right in front of the great place. And to see that your efforts or your dreams that finally launched makes you believe that there could be more, that everybody is absolutely capable of doing so much and a lot more. So here's to hoping that you can take home the belief that it is quite possible if you want to burn the midnight oil or if you just have the passion for it. Coming towards the end, this was very recent. This was last year. As part of being involved in these activities and contributing to the space sector and being a woman in the space sector, I was chosen to represent India along with a few other people as part of the Indian delegation. And we were sent to Europe for this purpose. As Mr. Dikshit also mentioned about IAC, we were also at the IAC conference that happened in France last year, followed by visiting Serbia for their World CanSat and Rocketry Championship. And we were also involved with a lot of embassies. So we all take a lot of pride in saying India can go a long way in doing this because we have so much potential. The cost benefit is so good. But we also need to understand that space for all, satellites for everybody is, and sharing technology beyond borders only will help us grow together. The energy of the entire ecosystem has to go up if you also have to go up there or build your standards higher. So in that effort, we decided to collaborate with many other embassies from across the Eastern Europe community. We were in Vienna, that's the UNOSA office, that's the United Nations Office for Outer Space Affairs, the first picture. Then this was at the embassy in Vienna, this was in IAC, and this is again in UNOSA. In all, sir? Who is the person there? Can you all tell me? Who's the person in the bottom left picture? Not me, you can see me, that's all right. Who's on my right? Exactly, that's the ISRO chairman. Today, as we mark a zenith in all our achievements thus far when it comes to moon orbiter missions, today, the person who chairs this ISRO fraternity that we know is the man that is here. How many of you all know him now at least? The next time somebody puts up this photo, you've got to be able to tell that previously it was Mr. Sivan, now it's Mr. Somnath. Yeah? So that's the ISRO chairman. Well, towards the end of it, I believe that representation is important, inclusivity is important, not in just terms of gender, but also ensuring that the weaker sections of the society, the weaker sections of the global community is pulled forward. As you grow, you might be a woman who wants to be in space. I'm committed to ensuring that women representation is enhanced by the day. And I hope a lot of young girls out here are also willing to take the plunge. And not just in terms of inclusivity of gender, but on the global forum, why is UNISEC India, why is WCR committing to having people from across the globe? Why are we working with Serbia, other Eastern European countries? It is to ensure that we give them what we already have and grow together. Yeah, so I hope you all can achieve the same. And having said that, I've written something, I've curated something very small that resonates with me, that keeps me motivated. It is when I meet people, for example, Padma Shri Vasagam sir. How many of you know Vasagam sir? Put your hands up. Okay, not bad at all. How many of you know Mailswami Annadurai sir? Put your hands up. For those who haven't, have you all watched the movie Mission Mangal? Who is Akshay Kumar? Exactly. So these people really are in the forefront of the Indian Space Research Organization. And Vasagam sir is renowned as the walking encyclopedia throughout the country and across. If you just spend about a few minutes with him, I'm deeply influenced by him. And I believe that what he can share in 5 minutes is enough for a lot of people for their lifetime. So he's able to trigger that acumen in you, that you can do a lot more. So when I was talking to him, I decided to write this. And I think I'm going to narrate it to y'all. I'm going to give this as an ode to everybody present here. Oh, all you young, curious, sagacious people, bustling with life and possibilities. Don't shy away when opportunities under the facade of challenges knock at your door. Don't wait for it to pass. Thou hast the power to create, and thou hast the power to defeat any obstacle. The minds are fluid, cascading rivers of untapped potential, and thy flow knows no bound. So step beyond the horizons you can see for what you believe you can be. Be limitless, be bold, but remember to be kind and be courageous, to take risks. For success comes not to those that dwell on former glories, but for him that knows the fight is a never-ending facade. It's a never-ending farce. So live for today. Know that your days are numbered. Don't squander away from your treasury one day at a time. May your todays be different from your yesterdays, and may the world make a beaten path to your door. Thank you. Have a great day.
Go.
Sir, total students ಇಲ್ಲೊಂದು ಅಖಿಲ listed ಇದೆಲ್ಲರೂ ಫಸ್ಟ್
Thank you, ma'am, for such an inspiring talk. Now we'll be wrapping up the second session for lunch, and at 2 o'clock sharp, we'll be here for the live streaming of the launch of Chandrayaan 3. Thank you.